Hello, this is a high-level introduction video for the project Online Betting Protocol. This is the main GitHub repo. As you can see, the contracts are already deployed on Covert testnet, and here is the list of all the contracts. This graph is the high-level overviews of each of the contracts would do under this protocol, and I'll be using it to describe how each contracts would interact with the rest of the contracts. Just a little bit background on why I came up with the idea to build an online betting protocol, because the current solutions for gamblers are either a random centralized website registered in Philippines or some random countries, and to place bet on those websites, they have to suffer from unfair rate, really unfair rate with huge commissions taken from the companies or the website runner, or they even risked rug pull. There's no guarantee that those companies would deliver the payout given the gambler or the bettor wins. So given the market size of online betting, I think it's natural that we need to have a decentralized solution for that. Okay, let's come to what these protocols have in terms of smart contract. First, we have a main contract. This is where all the dots are connected. We would have a court, which has the address hard coded in the main contract, and for any person who want to deploy an operator, meaning that they want to host a betting event, they would deploy it here, and the operator they deploy would have the address also updated in the main OBP contract. So all the listeners or all the people could listen to the deployment and know that an official operator is deployed. And likewise, a referee is someone who works more or less similar as an oracle. Referee would bond their tokens to be able to inject results into an operator. More on this later in the deployment video. And so this is the main contract. And this main contract would hard-code the address for a court, and a court is implemented as a proxy. So all the calls to a court would delegate to a court library. And the court is like the final arbitration. Whenever someone thinks a referee is cheating and inject a wrong result, this court would be able to confiscate the referee's bonding, given all the staker or people who have the abilities to vote against this referee. So there's a case opening and case voting capabilities in the court proxy as well as the library. And this is coded in the proxy pattern for upgradabilities, and we will deep dive in the court library later on. And referee, it's someone who safeguard the event result. Anyone can deploy a referee, but for a referee to be able to safeguard an event, there has to be OBP tokens bonded for the event, and for doing so, the referee can have a slice of the bet fee. This is to reward their risk taking, and also for injecting the accurate result into a betting event. And one more point on the court as well. The court would also receive a betting fee as a reward for also safeguarding the protocol. Last but not least, we need a betting operator. Betting operator is deployed, so all the gamblers would bet on the betting operator. They would place bet, they would withdraw, they would check out the events, and someone will wonder how the event details would be pushed on chain, and it's actually done by a hash. So the event details would be hashed with the KCCAK 256 algorithm, which is standard on Ethereum, and this hash would be initialized whenever an operator wants to deploy a contract, and this hash is immutable. So let's say this example, if I want to host an event for Liverpool versus Real Madrid, and I have some specifications, and this whole string would be hashed off-chain, and the hash of it would be pushed on-chain for this deployment. And anyone with the string can verify that, okay, if I hash this JSON, I will be able to verify that this is exactly what this betting operator is hosting for, and I can bet accordingly. That's pretty much the high-level overview. I will stop here. If you have interest in how each of these actors could interact with the contracts, please refer to the corresponding demo. Thank you for your time. This is the first part of the demo, and in this video, I would deploy a referee as well as a betting operator through the OBP main contract. To do so, first we need to get some OBP tokens. On the current testnet, this is just a dummy ERC20 tokens with the mint function exposed. So let me go ahead and mint some tokens. You can call mint. This would give me some tokens. And if we check the balance, it has given me 10 tokens. Cool. Now we go to the OBP main contract. There are currently 5 referees has been deployed, and I will deploy the sixth one. We can call deploy referee. In the backend, it would call a create to assembly function, so it would need a little bit more gas. Let's see. Okay, now the contract passed. We can see the 6th referee is deployed at this address. And on the referee, now we need to give it some OBP tokens so that it could help safeguard any events. To do so, we need to give it some OBP tokens, but before we can bond some tokens to it, we would need to approve the transfer of it. So we need to go ahead and call approve. The spender is this referee, and we can give it, we have 10 tokens. Let's try to bond 5 on it. Okay, we will approve 5 tokens. Once it goes through, we can check the allowance. We are the owner, and the spender is the referee. Okay, we are the owner. Yes, the transaction passed through. Now we can call the participate functions. When we call participate, we are allowing this referee to go to the OBP tokens and get 5 tokens from me. So I would do 5 here. And let's see. And if this transaction passed through, this referee will have 5 OBP tokens, and my personal address would have 5 only. So 5 tokens would be transferred from my address to the referee. Okay, done. So we transfer 5 OBP to this referee successfully. Now we can go ahead and deploy a operator. And to deploy a operator, if just to recall how an operator works, in the initializations, we will need a root hash of what this operating is hosting for, and this hash should correspond to the event details, and given the JSON or the event details should be hashed back to this on-chain data. So now I have this JSON, and this is just a mock event on some date and with some pool distribution, meaning that all the money from 1, 2, 3 would be allocated among itself. So this is just an exclusive set of events. So pool ID 1, ID 2, and ID 3 would happens exclusively. Only one of them would take place at the end. If this is the event detail and this is going to be the hash of it, and I would we quickly verify that this hash does not exist ever. Just in case there's a hash collision, someone deploy this hash, then there would be an operator address here. If we see 0, no one has used this hash when you can effectively use it. Then we deploy a betting operator with this hash. And let's see if this goes through. Okay, this goes in. And we can see where the operator is right now. The betting operator is deployed at this address. And this is the contract. One more point, so this JSON is actually off-chain. So as a betting operator, would be responsible for doing marketing or distributing this JSON. Otherwise, no one, neither the gambler or the referee would know this by the hash. So they would not know how to bet, they would not know how to inject the correct result. And now with the betting operator here, we need to do a few housekeeping first. First, we would need to decide which referee to help inject result into this event. As the owner of this betting operator, you could decide which referee to set. And it could only be set once, but it was not initialized, so we need to set it. The referee, like what we said, we have deployed the referee on the 6th one. So we would put this referee into the betting operator. This is our newly deployed referee. So you realize that a referee can be the same person as the betting operator. No one will stop them from being the same person. But if they cheat, you will see they would also be penalized because their bonded OBP tokens would be confiscated. So there's a mechanism to prevent them from cheating together by being corrupt. Okay, now this betting operator has set a referee, and the next thing it has to do is to set a bet token. A betting operator effectively could accept a bet token that is different from an OPP. So it could accept ETH, it could accept Web BTC, it could accept any tokens it wants. But this bet token has to be supported by the OPP main function. It is done in a way because all these bet tokens, some part of it would be collected as commissions for the referee, for the court, as well as for botting operator. And especially for the court as well as for the referee, these bet token would be traded for OPP, and there has to have a liquidity pool between this bet token versus the OPP token. So this is a minor detail, but for the sake of this demo, I would use the OPP token as the bet token. So there will be no trade logic involved. We just set bet token as the OPP token. Now, we see that this referee, and now the betting operator has set the referee. It has also set the bet token. As the referee, now you need to say that, hey, I gonna accept this betting operator. I would say, hey, I gonna help inject the result. And to do so, the referee has to call a verify function. And this referee has to specify that, hey, I gonna verify the result for this betting operator, and I gonna say, hey, I gonna bond some OPP tokens for this event, and we can bond. As we all know, there's 5 OPP in this referee. We can say, hey, I'm gonna bond all the tokens. And we know that there is the operator could take a max bet because we only bonding 5 OPP tokens. If say, hey, I'm gonna accept max bet of 500, then people will gonna question because you're only bonding 5 OPP tokens. Accepting a max bet of 500 would make you very suspicious because you could easily inject the wrong result and take the other side of your max bet. So we would also say, hey, we're gonna accept 5 OPP tokens, bet token, and this will make it very sincere because we are bonding 5 tokens to safeguard a max bet of 5. And this referee's ID is used because when people are betting or when the operator is inviting a referee, the logic would check back whether this referee exists in the OPP main contract. So we would need the ID, and our ID is 5, so we would write it in this way. Okay, this transaction passed through. Now we successfully deployed a referee. We have bonded money into it, and then we have deployed a betting operator. We have also initialized the betting operator with a hash of its event, and we have set the bet tokens, and we have also use a referee to accept the invitation of this betting operator. So we have already done the initialization part. In the next part of the demo, we would demonstrate how to make bet and how the referee could inject result into it. Thanks for watching. Hello guys, this video is the second part of the demo, and I would go ahead and make some bet. and also demo on how to check various data and matrix on the betting operator. Before I started, on the last part, we have deployed a referee and a betting operator respectively. And on the betting operator, actually, we can verify its information. We can verify that the bet token is actually set to the OBP tokens. We can also verify there's a court. This court is the court proxy. And we can verify the commission set to various party. This is denominated in 1 to the power 10 to the power 6. So this is 3%, this is 1%, and 1%. We can verify that the max bet is set to 5, and the referee's value at stake is also 5. So this information are all immutable and stored in the betting operator contract. Now, let's say if, and also the hash. I think the hash is on here. And it's converted into UIN256, but essentially it's the same hash. Recall that we have these betting map. Let's go ahead and say, hey, I want to bet 1 OBP tokens on the second ID. I want to bet that Manchester United wins. What I would do right now is go to the contract and place bet. I will place on the second item. I will place 1 OBP tokens. And the better can be set to any person. And of course, on this demo, I will set it to myself. And it's through router. This is interesting because actually when we are making a bet, we also need to do the approve tricks. If we are betting through a router, that means that this router, essentially we can approve the router as the spender of our OBP tokens. Otherwise, we need to approve these betting operator as the spender. And on the purposes of this video, I don't want to complex it. I will just approve this as the spender. Okay, I will approve this spender. I will approve, because I'm making a bet of 1, I will approve 1. If we use a router, we don't need to approve each and every betting operator. We just need to approve each token for the router, and the router will do the betting for me on behalf of me to that betting operator. But I don't want to complicate this demo, so I will just use this one. And after we approve this betting operator as the spender, then we can bet on it. So we are not going through the router, so we put a 0. Okay, now we have placed the bet. Let's check the pool. We can see that the pool has a pool size of 0.95 OBP tokens right now. And because the event is not closed, so there's no payout details. 5% is deduced because the fee is distributed to the operator, the referee, and the court respectively. And we can see that the fee to the court is 1%, to the operator is 1%, and to the referee is 3%. And this concludes the second part of the demo. Hello guys, this is the third part of the demo when I would use the referee to inject results into the betting operator. Recall in the last demo, we have placed a bet on the bet item tool on 1 OPP tokens. 5% is split in for the referee, betting operator, and the court respectively, leaving 0.95. I've also initialized another gambler and put in 2 OPP tokens for the pool number 1. So the pool now has a little bit more money, so we can see how the injections would work in this way. Now, to give you a little bit more background on how the results is encoded, actually each result is represented in a UN 256 data, with the first 112 as the item ID, the second 112 as the payout, and the last UN 32 as the last updated time. On the referee, there's an arbitration mechanism when before the from when the result is announced to up to the arbitration window, it cannot close the event. It has to allow the, people to see it, and if there's anything wrong, it can also make a correction of it. This is to prevent, to minimize the mistakes. So it is an arbitration window. Anyway, so when we announce result for our betting operator, and this is the result set, we are putting value for the item number 2, the pool number 2, and this is the payout for it, which is 2.9 OPP multiplied by 10 to the power 18, and this is the timestamp. Let's go ahead and inject this result. We can actually see this result in the referee contract. We can see its result for this betting operator. It's actually stored here. You need to have some decoder to kind of know what it means, but it's actually stored on chain. And after the arbitration window, in this demo, I use a very short window, like a few seconds, so we can push the result as soon as I have injected. So I can go ahead and push result or use push result batch. They are more or less similar. The push result would push a custom index, whereas the push result batch would push the whole bytecode. I'll use push result batch, so it'll be easier, because on the announce result, you can also announce multiple pool. So the push result also takes the whole bytecode and kind of push it. So I will push result for this betting operator. Let's see, seems there's an exception will be thrown. Let's see how it works. Okay, there's one checking. If the payout is more than the total bet size, then it would revert it, because you cannot give money that's more than your total bet amount. So maybe the bet amount is wrong. Let me verify it. Oh, I think I do a math mistake. Instead of 2.9, we are having because there's only 0.95 to 1.9, so we're actually having 2.85 as the result for the total payout. Okay, so it is a good demonstration, because if we are injecting an amount more than the total bet size, then you cannot announce such a result. So we made a mistake on the data, so I would just repush it. And we can verify that the result has been updated. It will not overwrite stuff. This mistake would be recorded. we just push the result over the it. And actually, when the referee is, when the betting operator is reading this payout, it would do a sequential update. So it will update the first one, and then it will update the second one. So making that updated to the latest value. Now we can go ahead and push this result. Let's see if it works. Finger crossed. And even though there's a little window, but for the sake of the operation, a referee should close the item first, and then it can count all the betting amount and then distribute the payout based on that amount. It's a bit dangerous to inject the result first and then close it, because during the event being open, actually other can continue to place bet, and it makes your payout not accurate or delay from time to time. So as a practice, it should close the item first and then inject result or announce payout result and then push it. So once the event is closed, then I can go ahead and claim my payout. I can check the payout by my result. Since I have placed the bet, I can check my items. And wow, I can check, I can see that I can claim this result. So I will go ahead and I can also check the pool. I can also check various pool, whether there's a payout, aggregate payout. And for me, since I can get this amount, I can go ahead and withdraw my money. And withdraw my money. And I should have that 2.85 OBP deposited. Yep, I got my money back. Awesome. And that's conclude the whole demo video. Hello guys. This is an extension part of the demo. In the previous sections, we have covered some workflows of the referees, of how to deploy a betting operator, how to make bets and claim your P&L. Those works fine given everybody is acting honestly. But since we all know a betting operator and a referee could be the same person, the court is here to prevent them from cheating and to safeguard the honesty of the protocol. And we call that the court is actually deployed as a proxy, and it would be delegating all the calls to the court library. And over this library, this would be how the preventive measure would be taking place. Now let's take a look at how the court library works. Since it's an ongoing process, I'm not doing a complex setup here, just going through the code. On the court library, everyone can stake their OBP tokens here, and by doing so, they are eligible for a voting. And because we all know that there is a commission, a slice of the betting fee for the court, and this staker would be eligible for splitting that commission for the compensation of the OBP staking. And there's a voting window here. This is where the amount of time that a case can be voted. And in the case that somebody has cheated, especially for some referee is cheated, then anybody can put in a ruling specifying on which operator this referee has cheated. And you want to raise this case so that this voter can then start voting on it. And this voting would then be evaluated. This is the function where you can suit some person. You initialize a case. And anybody who staked the OBP can then start voting. And they would choose to vote whether this operator Since one operator can only bond with one referee, so you can only specify here, and you decided how much of your voting power is used to vote for this case, and whether you want to vote as corruption or not. And then you can update your vote. You can, use more or less voting power depending on your convictions, and once the voting window passes, then we can update the final result of these rulings, and then we will decide based on whether the is corruption vote is more than the is not corruption vote, to decide that this referee is corrupted or not. And once this result is updated, this court would be able to confiscate the referee's bonded amount, meaning that it would take the OPP in the referee contract address and send it to the betting operator if the referee is deemed is corrupt. So how this can be done is actually through the OPP main. We call that all the referee is deployed from the OPP main. This referee has actually embedded a confiscate function, and this confiscate function can only be called by the court. And this confiscate function, once being called, would take the amount that it has bonded and send it to the operator. And when this money got sent to the operator only cannot take it. Just the people who put the bet but haven't claimed any money would be eligible to split these OPP tokens. Now, on this mechanism, the benefit is that even though the referee corrupt or cheat with the betting operator, the bettor could be compensated by the amount bonded by the referee, take it, and run with it. So that's the beauty of smart contracts and decentralization. Of course, on the card, there are some enhancement needs to be done. This is just a demo version 1. The voting may not be gas efficient. The upgradability is using transparent upgradable contract. It could use UUPS, but that's the design patterns of the court. On the summary, the court would confiscate money from the referee, send it to the betting operator, where the person who hasn't claimed their P&L could take those OPP and run with it for the compensation of their bet. If the referee is cheated and the case is rooted that the referee has cheated over the court. And on the court, whoever has OPP and stick there would be eligible for the voting. So the whole OPP, holding OPP and sticking in the court would give you the power to safeguard the accuracy of the protocol. And since the hash of the betting operator as well as its details is all open source, and most sport events has the result exposed to everybody. So if you are a court member, you can check the root hash, you can check the event detail and see whether the result is injected accurately. It is something that everybody would be able to do so. That's the design patterns and the assumption taken for such a implementation. Thanks for watching.